Hi, everybody. I'm Jesse Manship, the Technical Service Engineer with Madico. And I'd like to welcome you to Madico's April webinar series. Thank you so much for attending our online training. Madico's Technical Service Department is here to help support our dealers, their customers, and our Madico sales team. We'll offer support on commercial solar and safety jobs, answer questions on a variety of topics from our films to glass, our warranty, energy analysis, and film to glass compatibility. Further information is available on our website. We also have Madico's technical resources available at Madico U, madico.com/MadicoU, or by following madico.com and clicking Madico U in the upper bar. Technical resources are just one part of Madico U. Technical resources and film benefits, glossary of terms, and film facts. In addition, we have product training videos. This is a list of some information on Madico U, a glossary of our solar optical properties, tools, some of which I'm going to discuss today, installation instructions and tips, and also frequently asked questions. So today, my goal is to give you a guideline on preventing glass failure, film to glass recommendations, glass and window construction basics, the causes of glass breakage and seal failure, the effects of installing film on glass, basic guidelines for preventing glass failures, our film to glass recommendations, and where to seek extra help. So these are the types of glass I'm going to go over: flat glass, annealed, heat strengthened, tempered, and chemically strengthened. The float glass process is the most common method of flat glass production in the world. This process basically involves melting silicate, lime, and soda into a furnace and floating it onto a large bed of molten tin, hence the name float glass. This mixture slowly solidifies over the molten tin as it enters the annealing oven, where it travels along rollers under a controlled cooling process. From this point, the glass emerges as one continuous ribbon and is then cut further and processed to fit the customer's needs. The major component of soda lime silicate glass is silicon dioxide, which is simply sand. Other ingredients such as soda and lime are added to lower the melting temperature and to promote optical clarity. The color and solar optical properties of clear glass can be altered in two ways. First, the glass can be tinted by adding small amounts of metal oxides to the existing ingredients. For the example, the addition of iron oxide produces a green glass. Bronze and gray are produced by the addition of selenium and nickel oxide. Secondly, a thin metal coating can be applied to the surface of clear or tinted glass. This is known as coated or reflective glass. The raw materials are mixed and then they enter the furnace. Once melted, the material becomes molten around 2,800 degrees Fahrenheit. Glass and bubbles are removed in refinement and then cooled to control the viscosity. Liquid glass is then floated onto the molten tin around 1,800 degrees Fahrenheit, forming a ribbon. Since the glass is highly viscous, it doesn't mix with the molten tin. This produces a flat contact surface. The thickness is controlled by increasing or decreasing the speed at which the glass spreads. Once leaving the tin, the rigid ribbon passes through an annealing chamber where the temperature of the glass is lowered from 1,050 degrees Fahrenheit to 480 degrees Fahrenheit. Further cooling takes place and then it's cut into sheets at the desired size. The tempering process consists of several steps. First, the glass is cut to size, followed by washing, then heating the glass. The glass is heated to a plastic state around 1,200 degrees Fahrenheit, and then by computer control, the glass is moved into a quenching area. This is where it's rapidly cooled by a series of high-pressure air nozzles. The rapid cooling induces compression stress into the glass surface while the center remains in tension. Although the physical characteristics are unchanged, the additional stress created within the glass increases its thermal and mechanical strength. This is what's important to us. After that, the glass continues down the rollers to cool more and then be packed and shipped. So what's the difference between tempered glass and heat strengthened glass? The heat strengthening process is very similar to that of tempered glass, but it's at a lower levels of surface compression, resulting from a lower cooling quench. Heat strengthened glass has a mechanical strength about twice that of annealed glass, and if broken, breaks into large pieces from from the edge and does not fracture into small fragments like tempered glass. The breakage characteristics allow the glass to remain in the window frame as the large pieces support each other in the opening. Heat strengthened glass also has high thermal strength like tempered glass and is resistant to thermal stress breakage associated with the high performance tinted or reflected insulating units. Heat strengthened glass also provides resistance to thermal breakage caused by heat buildup in spandrel situations and the probability of nickel sulfide inclusions in introducing spontaneous breakage is non-existent in heat strengthened glass. Heat strengthened glass is often used in laminated glass because it allows better interlayer adhesion than tempered glass due to the flatter nature of the heat strengthened product. The flatter finish also results in less optical distortion in the building facades. It has excellent breakage characteristics and prevents fallout. As a result, heat strengthened glass is often used in curtain wall facades in both division and spandrel applications. In some situations, though, heat strengthened glass is not suitable. For example, when safety glass is required for human impact safety. For that, you'll have to use tempered glass. Chemically strengthened glass is a type of glass that has increased glass strength as a result of post-production chemical process. When it's broken, it still shatters into long pointed splinters similar to float glass. For this reason, it's not considered safety glass and must be laminated if it's a safety glass is required. The chemical strengthening is by surface finishing process. Glass is submerged in a bath containing potassium salt around 300 degrees Celsius, which is about 572 degrees Fahrenheit. This causes sodium ions in the glass surface to be replaced by potassium ions from the bath solution. These potassium ions are larger than sodium ions and therefore wedge into the gaps left by the smaller sodium ions when they migrate. This replacement of ions causes the surface of the glass to be in a state of compression and the core in a compensating tension. Chemically strengthened glass has little or no warp, optical distortion, or strain pattern. This differs from tempered glass in which slender pieces can be significantly bowed. Also, unlike tempered glass, chemically strengthened glass can be cut after strengthening, but it loses its added strength in the region about 1 inch from the cut. Similarly, when chemically strengthened glass is deeply scratched, this area loses its strength as well. Typical glass colors and coatings. Standard clear glass has an inherent green tinge, which is more apparent when viewing the edge of the glass or in stacks. This is due to the iron content in the silicate. Clear, low iron glass contains approximately 1/4 of the iron content of standard clear float glass, providing an extra clear glass that is crystal clear in appearance. Tinted float is produced by adding metal oxides during the float glass production. The most common colors are gray, bronze, green, and blue. Apart from its function and aesthetics, tinted glass is primarily designed to reduce the solar heat gain, UV, and glare. Tinted float glass achieves its performance by absorbing solar energy, so sometimes it's referred to as heat-absorbing glass. This heat-absorbing quality means the glass is thermally stressed, so some thicker or darker products may need to be toughened to avoid thermal stress. Special coatings can be applied to the float glass to make it reflective to shortwave radiation, that's the IR that you feel from the sun, or from long-wave radiation, that's the heat that's inside of a building. These coatings go by a variety of terms. The two main types are pyrolytic coating, and this is a metal oxide coating applied on line, so during the glass production, at high temperature. This coating is fused into the glass surface, making it extremely hard and durable. It could be called online or hard coating. A sputter coating is offline in special equipment. This process deposits the metal particles onto the glass in a vacuum chamber. Almost any non-magnetic alloy can be sputtered, the more common being stainless steel, silver, and titanium. Performance characteristics and color depend on the alloy and the coating density. In general, they have better solar control performance than pyrolytic coated glass. Traditional reflective glass has a mirror-like appearance and reflects and absorbs a major portion of the sun's direct short-wave radiation. The degree of reflectivity is dependent on the type of the coating and the orientation of the glass. The use of reflective glass is most popular in commercial glazings as it provides superior solar control performance to clear or tinted products. Low emissivity coatings are traditionally clear and are designed to reflect long wave radiation. They are available in both pyrolithic and sputter coatings, and the performance varies. Some products have low E coatings to reflect long wave radiation as well as the sun's short wave radiation. Sputtered coated low E glass has transparent layers of silver and metal oxide sputtered onto the glass surface. The metal oxides which surround the silver protect and suppress the visible reflectance of the silver. Patterned or obscured glass is manufactured in many different thicknesses and has a variety of patterns. Patterns are usually not strengthened or tempered due to the variation in the depth of the pattern. Etched glass has one side which has been treated with acid to produce a grainy or satiny finish. These are the types of basic windows that you can encounter in the field. Monolithic are typically of older homes or businesses consisting of a single pane of glass at a constant thickness. The glass can be annealed, heat strengthened, or tempered. Laminated glass is bonded together multiple layers of glass, typically with PVB. Usually laminated glass is 2 layers of the same thickness of glass and a single interlayer. The interlayer holds broken glass together in the event of a breakage. Glass can be annealed, heat strengthened, or tempered. Insulating glass is manufactured by enclosing a sealed gas between 2 or more panes of the glass. The glass is separated by a spacer. Desiccants are added to absorb any water within the unit to prevent fogging. Filled with noble gases to improve insulation. The glass can be annealed, heat strengthened, or tempered. Laminated glass is just like insulating, except 1 or more of the panes is replaced with a laminated glass. There are some benefits to having insulated units. You have improved heat gain reduction and heat loss over monolithic glass. They have solar and low E coatings to lower the shading coefficient and the solar heat gain coefficient. The space between the panes is filled with noble gas to lower the U factor. Some insulating units offer moderate UV blockage, and they all offer increased sound comfort over monolithic glass. And using a laminated pane will reduce the noise even more. There are many types of windows and glazing systems. The frames can be aluminum, wood, and vinyl. Aluminum window frames are light, strong, durable, and easily extruded into complex shapes required for many windows. These are most commonly found in the office settings. Non-metal frames like wood, vinyl, and hybrid frames that use 2 or more materials are most common in homes. Wood is used because of its availability and ease of milling into complex shapes. It's not the most durable because it's susceptible to rot. Vinyl is versatile plastic with good insulation values and very low maintenance. Hybrid systems like vinyl and aluminum clad reduce exterior maintenance while still having the interior look and feel of wood. Dry glazing is the installation of glass using extruded gaskets in PVC or EPDM to 1 or both sides of the glass to provide a compressed weather seal. No sealants or putties are used in this system, and the windows are designed to be self-draining. In some low exposure conditions, glazing tapes can also be used on the inside. Wet glazing is the installation using sealants and butyl tapes to bed the glass and seal it to the framing. Silicone is the most commonly used, but polyurethane and polysulfide sealants are also used. Structural silicone glazing utilizes special grade silicone to adhere the glass and cladding materials to the aluminum subframes. So what happens when we apply film? The reflectance plus the absorption plus the transmission all equals 100%, that energy that's coming from the sun. So we commonly refer to this as the RAT equation, reflection, absorption, and transmittance. The higher the absorption, with the less reflection and less transmission, the hotter the glass will become, leading to more thermal load on the glass edges and the surface. This in turn will increase the thermal stress conditions. So you ask yourself, what causes glass to break? Thermal stress, temperature fluctuation, uneven solar absorption, different temperatures throughout the glass, edge stress, shading, glass bite, interior shades and positions. Thermal stress develops from differential expansion with an annealed glass caused by heating or cooling. In a window, the edge of the glass is shielded from the sunlight by the frame. So the edge, the covered edge, will be cooler than the central area, which is exposed to the sun. The expansion from the central area will cause the glass to stretch, and yet be resisted by the cooler covered edges, which will, as a consequence, develop tensile stress. If this stretching of the edges becomes sufficiently large, then the resulting tensile stress will be sufficient to break the glass. We call this a thermal fracture. When the tensile stress in the edge exceeds a critical point, a crack will form. The magnitude of this critical point depends on the strength of the glass edge. A clean cut edge is the strongest, as the cutting produces the least amount of damage. A polished edge is the next strongest. The actual edge strength depends on the quality of the glass edge. So if there is damage to the edge, this will reduce the strength and increase the likelihood of a failure due to thermal fracture. The probability of breakage becomes significant with damaged edges. The main thermal stress factors are glass type, coating type, and location, heat traps, which are blinds, drapes, or drop ceilings, exterior shading, heating and cooling vents, and the framing system. Glass type is one of the largest contributors to thermal stress. The more the glass absorbs before the film is applied, the higher the risk of a thermal fracture. Colored glass and high-performing glass absorb more than clear glass. Also of concern is low E and solar or reflective coatings. Just like films, these coatings absorb, reflect, and transmit the energy from the sun. This is why it's important to know where the coating is located. On the number 3 surface, the coating is on the same pane of glass that our film is applied. Since the coating absorbs and the film absorbs, coatings on the number 3 surface are more risk due to the higher absorption. When the coating is on the second surface, the risk is lower, but for some of our products that are highly reflective, this means we're reflecting the energy back through the outer pane. That coating is absorbing some of that reflected energy as well. Heat traps, blinds, and shades are not, when the interior shade devices are not properly vented or positioned, heat traps can be established, giving rise to high thermal stress. They reflect the heat back in towards the glass. They trap hot air in between the glass and the blinds. It's dependent on the type and color of the device, how much ventilation they have, the spacing between the device and the glass. At least 2 inches is required, 6 or more is preferred for spacing. Drop ceilings can trap hot air in between the glass and the ceiling as well. For exterior shading, I'd like to emphasize that the outdoor shading is a dynamic design. It varies seasonally due to changes in the incident angle of solar radiation. In addition, an important consideration is that shading and reflection patterns can be altered long after construction is completed, with the addition of new or adjacent structures. Generally, shading patterns with 50% or less coverage of the glass are most unfavorable because they cause the highest temperature gradients. This is an example of thermal stress in glass. It's important to understand the glass bite. As you can see here, the edges of the frame keep the perimeter of the glass cool in comparison to the center, resulting in the most stress on the glass. Large bites increase the cool area and in turn, the stress on the edge of the glass. Some examples of shadow conditions that can affect thermal stress. A linear shadow, it's one that's straight up and down. An angular shadow, you can see it's a right angle there. An L-shaped shadow, you've got 2 sides of the window that are blocked, or a corner shadow. This is an example of just a linear shadow, and you can see the stress extends much greater than when we had just the edges. The frame in which the glass is captured affects the temperature of the edge of the glass. Thermal stress will be increased as the thickness of the metal increases. Metal framing systems that include a thermal barrier reduce the thermal stress on the indoor glass of the insulating unit. Massive concrete or metal frames in thermal contact with the glazing rebates have a great heat capacity and will result in increased thermal stress in the glass when the concrete or metal becomes cold and does not warm up as fast as the central area of the glass unit when exposed to the sun. Heating and cooling vents that blow air against the glass can form hot or cool spots on the glass, just like a shadow does. These are some risks when applying film. Monolithic glass that's thicker than 3/8 of an inch. This is over 2 times more absorbing than 1/8 inch thick glass, 18% versus 8%. Tinted monolithic glass can be up to 90% absorbing. This would be very dark, by the way. A 50% VLT blue glass, for example, would have an absorption around 60%. Laminated glass, Madico only recommends one film applied to laminated glass, our Nova 70. We don't recommend using other films since the film can absorb too much energy, and this can lead to a crack or delamination of the laminated glass. Insulating units have their own risks, ones that are greater than 40 square feet, if they have tinted glass, triple pane units, and certain low E configurations. The best case is if the window or the laminated glass is made from heat-treated or tempered glass. Heat-treated glass is able to absorb a tremendous amount of energy without the risk of a thermal fracture. Conditions that cause insulating glass failures. An IGU seal can fail when the desiccant used to keep the space dry no longer absorbs moisture that migrates. This can happen because of natural aging or because of unsatisfactory design that allows moisture to become trapped near the edges of the IGU. Other issues can be skips or voids in the sealant, incompatible glazing materials with the sealant. Adhesion of the sealant to the glass could fail, elevation changes without proper ventilation, and also natural aging, temperature, pressure, humidity, and UV exposure. You can test for seal failure by using a frost point tester. This device lowers the temperature of the glass, which allows any moisture that's within the IGU to condensate on the glass. You don't need a frost point tester though. Ice will do. Hold the ice to the surface of the glass for a couple minutes to lower the surface temperature of the glass. If you notice that there's internal haziness inside the unit, then they'll see that haziness when the weather gets cooler. Film should not be applied to windows that have existing seal failure. So when you're on the job site, what do you want to review? The glass bite, how much is it? Thermal isolation. Examine the gasket and the sealants to ensure that they are resilient and will allow for thermal expansion. What's the condition of the framing system? Is it old and is it damaged? Drapes, blinds, shades? Are they ventilated? Do they allow the heat to escape? Heating and cooling vents, are they pointed towards the windows? Exterior shading, look for trees, homes, buildings. Imagine the position at different times in the day. Will shadows form on the window? And for the weak functionality, look for clogs that will cause rainwater to accumulate in the frames. Tools to bring. A dew point frost testing device. Also look for failed seals that don't require using this method. Ask if they had to replace windows in the past. Glass thickness airspace gauge. This is a must for measuring the glass and airspace thickness. Toughened glass meter, another great tool for identifying heat strength in glass. A low E detector, perfect for identifying the location of the low E coating. Is it on the number 2 or the number 3 surface? A tape measure, a camera, a product reference sheets, and evaluation sheets and summary sheets to record your data. Madico has 3 film to glass charts to assist you in choosing the correct film for the glass and windows that you encounter. The chart has the films to the left and then along the top, the various glass configurations. Approved window films show a green check. Films that require a film to glass application are indicated with an orange circle, and films that are not approved are shown with a red X. These are available digitally and then they're also printed too. So in conclusion, most films may be used for most applications. When using the film to glass recommendation charts, make sure that your installation is approved. When in doubt, contact technical services and we're here to help you. So we have some upcoming webinars that we'd like to let you know about before we finish up. On April 16th, we're going to talk about shopmadico.com. And then on April 27th, we're going to go over some types of glass meters and how to use them. And then on April 29th, we're going to be doing a ClearPlex installation training. And that'll wrap up the training for today. I think we may have some questions. I saw a bunch of flashes going on now, so as we're talking.
Thanks, Jesse. It doesn't look like we have any questions right now.
Okay.
But
I don't know what
I
that
want to give
flashing
people
was
just, Yeah, people were entering information in the chat box, but I just want to give everybody just a minute if they do have questions to enter them. Find your chat box and enter any questions into chat. We do have about 4 minutes left. If anybody wants to ask a question, we have a technical expert here that can answer them. Oh, we do have a question. Outside the United States, we see a lot of reference to heat toughened glass. What does that mean?
So I'll go back up. When we're talking about, sorry if the chat's in the way, guys. Oops. Sorry, I'm new to this thing called a computer here. So when we're talking about tempered versus heat strengthened, and then, so tempered overseas is commonly referred to as toughened. And it's just a different word for the way that they call things. So when we were talking about tempered, it's also referred to as toughened overseas.
Okay, and then another question came up. I ran into bullet resistant glass at a bank. Can you install film on that?
Really dependent upon what they're trying to do. So if it's bullet resistant glass and it's blocking the teller and it's not going to receive any solar exposure, you can install film on there, but you have to be careful because you want to make sure that the surface that you're applying to is actually glass. Sometimes they use polycarbonate or a different surface on the outside to control spalling, and you may not be able to apply film to it if it's not glass. If it's a window that's facing the exterior of the building, you need to be very careful about installing film on it because it's a thick laminated piece of glass, and you have to be very specific with them on what you're trying to do. I'd recommend that you contact us first before you film anything that's bullet resistant, because the last thing you want to do is accidentally cause any damage to that very expensive glass, or the worst case would be if it's cracked and then they have to shut down that section of the bank to protect their employees, and they could get very upset at you.
Jesse, another question just came in. Why
Sure.
do tempered units appear to have two different surfaces? One is always more gritty than the other side.
So when they make glass and it's floating on the tin, when I showed this rudimentary drawing here, one surface of the glass is exposed to the air and the other surface is on the tin. The side that's exposed to the air, you can imagine, gets little pieces of dust and things in it. And so when it gets quenched at the end, after they cut it, one side is a little bit smoother than the other. And so that's why you notice it. Most of the time, the glazers are supposed to install that gritty side towards the inside. But every once in a while, they do it backwards, and that's when you notice it, when you run your knife over it, and you go, oops, and then you have to clean it with the white scrubby instead.
Okay, and then one last question, Jesse. Somebody asks, how can I know when a window's tempered? Most times it has a stamp that says it, and it makes it easy to know, but sometimes there's no stamp.
Sometimes the stamp is hidden or it's up at the top. There are tools, and I have another class that's coming up, but if you use this strengthened glass detector, it's very, very accurate at determining if the glass is tempered or heat toughened, as they refer to overseas. What you're looking for with these detectors is the strain patterns within the glass. So if you've ever worn polarized glasses and you notice how like the back windows or the side windows of cars, they look checkered or they have the weird pattern to them, that's what this device can see and let you see it from the inside without having to wear sunglasses and view it from the outside.
Great. Thank you so much, Jesse, and thank you everyone for attending. This will end our webinar.
Thank you, everybody.